Okay, welcome everyone. Today we will talk about the Lean Six Sigma topic in our course material. Lean Six Sigma, it is a combination between the two world classes approaches, the Lean and the Six Sigma. Why is this combination between these two methods? What is the use of them? And how it is commonly known these two names they become together. We have covered Six Sigma in previous recorded sessions. Today, the first time we introduce the Lean, and if you search, it is commonly to be seen those two together, the Lean and the Six Sigma, and the abbreviation for them is LSS. The Lean, as the Six Sigma, came from the manufacturing, but the Lean is focusing on reducing the waste, whereas the Six Sigma is focusing on reducing the variability. The Six Sigma, we have talked about it earlier, that is founded or it was carried out from Motorola and General Electric. The Lean, on the other hand, was founded and carried out from the practice of Lean principle in Toyota production, and they call it the Toyota production system, which carried the Lean manufacturing that is later converted to service industry. Toyota is not just a well-known name in automotive industry. It is one of the pillars for many of the quality tools that we are learning today. It is one who carried the Lean manufacturing to practice, and it is later converted or conveyed to service industry. Toyota, there are many or several books, authors, they have written many books about Toyota, how it was becoming from the beginning until now an inspiring company for others, how they improve quality and conduct quality tools and methods in their industry. They have their own system, they call it Toyota Production System, and in this link here we will watch together a short video, what is Toyota Production System and what is relying on, and how is the Lean came from this Toyota production system. So let's watch the link together.
Toyota knows how to make cars. It does it so well, it became the first company to produce more than 10 million a year. Its success is rooted in a special system and began what's now known as lean manufacturing, an ethos emulated by companies around the world to make products faster, cheaper, and better. Here's how Toyota changed the way we make things. Following the Second World War, Japan was left in a precarious economic position.
Steel and other metals are scarce.
Already disadvantaged by lacking natural resources, materials were hard to come by, and companies had to be creative to compete. Toyota's founder, Tsukichi Toyoda, had started a loom business, but it was his son Kichiro who founded the motor company in 1937. They were used to working within narrow margins. As the shortage of materials increased during the war, the number of headlamps on its Model K truck was reduced to one, and it only had brakes on one of the axles. The turning point for Toyota's production system would come in the early 50s, when Kichiro's cousin Eiji would travel to the US with a veteran loom machinist, Taiichi Ono. They visited Ford's River Rouge plant in Michigan and were impressed by the scale of the operation, but knew that in cash-strapped Japan, companies didn't have the resources for such a system. Having months' worth of stock sitting in a warehouse would tie up precious capital they didn't have. Instead, what truly impressed Ono was a visit to a supermarket, a Piggly Wiggly, according to legend. Japan didn't really have self-service stores at this point, and he was struck by the way customers could choose exactly what they wanted, when they wanted. He decided to model his production line on a similar idea. With the supermarket formula, only enough parts were produced in the first phase to replace what was used in the second, and so on. This is where the just-in-time system really took shape. Toyota was able to eliminate much of the waste in Ford's system, making smaller numbers of parts to be used when it needed them, allowing the company to operate on a tighter budget. As part of this, Ono developed Kanban, a sign-based scheduling method which shows goods in production, and goods out. It's now seen as a precursor to barcodes. Ono and Toyota also noticed that American car companies were still employing many of Henry Ford's early production techniques. They kept operations at full tilt in order to maximize efficiencies of scale, but then had to repair defective cars after they rolled off the line. Ono believed this caused more problems and didn't encourage workers or machines to stop making the mistake. So he placed a cord above every station which any worker could pull to stop the entire assembly if they spotted a problem. The whole team would work on it to prevent it from happening again. As teams identified more problems, the number of errors began to drop dramatically. Combined with a culture of continuous incremental improvement called Kaizen, the Toyota production system built a brand known for making reliable and affordable cars. But Toyota was also getting good at producing cars quickly. In 1962, the company had produced 1 million vehicles. By 1972, they'd produced 10 million. It was around that time that the efficiencies of their factories enabled Toyota to produce a car every 1.6 man-hours, much lower than their competitors in the US, Sweden, and Germany. And as the oil crises of the decade sent gas prices higher, cheap-to-run Japanese cars became much more appealing to Americans, whose powerful but gas-guzzling vehicles suddenly became very expensive to run. Today, Toyota has made over 250 million vehicles. Others have looked to them to learn the lessons of lean, combining craft with mass production, avoiding waste while striving for constant improvement. Boeing is perhaps the most famous, restructuring a plant to better suit TPS. Intel is another long-time lean ambassador and is exploring the principles in the context of AI and the Internet of Things. A Canadian hospital even used Toyota's system to decrease wait times in its ER. The Toyota production system changed not just how cars are made globally, but how we approach making things full stop. It also showed that there's always a better way to make a product.
Okay, we saw from the video how is the Toyota production system inspired the other companies, not only in manufacturing. We have seen that in healthcare, also in the service industry, that lean can be implemented to reduce waste, as well as also to improve quality, reduce cost, and the leading time. The Toyota production system, it is based, or it achieves using two major concepts. Those two concepts or pillars, they call them just-in-time and Jidoka. What is just-in-time and Jidoka? We will continue also with other short video, and then we come back to explain in more details about those two concepts and the tools that underneath them.
Let's say your business is doing well and you're thinking of expanding. That's great, but it's also the riskiest time for your business. In fact, many businesses don't survive the transition. Should you throw money at the problem by investing in new equipment or hiring more people? Should you make your staff work more overtime? Your answers to questions like these can make or break your business. And that's where Lean comes in. Lean is a philosophy about delivering value from your customer's perspective, eliminating waste, and continuously improving your processes. Lean can radically change the way you do business. Lean management is based on 4 principles. The first principle is pull. Rather than producing as much as possible, customer demand pulls goods or services through the manufacturing process. This minimizes overproduction, inventory, and ultimately working capital. The second is one-piece flow. Focusing on one single piece at a time minimizes work in progress, process interruptions, lead and waiting time, while increasing quality and flexibility. The third is tact. It's the heartbeat of a lean system. It's how fast you need to manufacture a product to meet customer demand. Tact allows us to balance work content, achieve a continuous flow, and respond flexibly to changes in the marketplace. And the fourth is zero defects. Mistakes happen, but a lean company doesn't pass on defects. Mistakes from previous steps must be fixed before going on. Combined with a robust continuous improvement process, the 4 principles of lean management will help your company stay ahead of the competition in a constantly changing marketplace. So, if you're ready to begin your lean journey, contact us today.
So what we get from those 2 short videos, that the lean principle is relying on some concepts. In this last video says that the 4 just-in-time, takt time, the continuous flow, those, all of them comes under those 2 pillars, the just-in-time and Jidoka. What is just-in-time and Jidoka? This is, they call it the house of the Toyota production system. The Jidoka is a Japanese terminology that is to stop and notify for abnormalities in the manufacturing, or even if you are going to apply it in the service. The just-in-time is to make sure that the process flow, it is as much as possible has reduced the waste and reduce the leading time. The objective or the goal for those 2 pillars is to have the highest quality, the lowest cost, and the shortest leading time or processing time. It is also based on other 3 common tools for continuous improvement, like a known name, a well-known name, Kaizen, standardized work, and Hijonka. We will come and discuss all of those tools in the coming slides, but first let's explain the 2 pillars, the just-in-time and Jidoka. The just-in-time means the right parts reach the assembly line at the time they are needed, only in the amount required, meaning that you don't do overproduction, you don't have over parts in your working area, you don't have unnecessary parts in your working area. That is the concept of the just-in-time. There are tools and techniques under the just-in-time concept, which are the continuous flow, takt time, the pull system, and we will come to them in the coming slides. The Jidoka is providing machines and operators the ability to detect when abnormals or out of normality conditions happen, as well as separate the work from the human and the machine, and give both on each of them the ability to detect the abnormality. And the cause or the reason or the goal of that is to reduce defects. Defects happen in the manufacturing, even in automated machine. But to reduce them, you need to have tools and techniques. And one of them is the concept of the Jidoka. Let's take, even here in the class, how we stop abnormality of absent students. When attendance is taken by the instructor, the system in the university automatically calculate the absence of the students and give the alarm of the percentage of his absence during the semester before he achieved the 25% of absence that will prohibit him from attending and continuing the class, and he end up with denied to be taking the final exam and taking a DN grade. So this is one of the JDoka that we have it here in the school, in our classes, as a concept. This can take variety of applications. Your seat belt alarm, this is considered to be to stop you from having an error by driving without a seat belt, because considered to be breaking the safety rules, and so on. In this video, we'll give you also a short video that talks about the JDoka, and you see it, how it's in the manufacturing system and how it becomes in reality.
JDoka enables the production of only quality products by automatically eliminating the production of defective products at an early stage. The key to JDoka is that machines are made to adjust to workers, rather than forcing workers to keep pace with the machine. To implement JDoka on the line, we have incorporated intelligent automation in our production equipment and refined work procedures for our teams to build quality into products at each point and prevent defective items from going on to the next process. One such idea is the pairing of our rope switch and andon, an electric signboard on every section of the line which provides a visual control tool. With andon, every team member has responsibility to the extent of stopping the line if they see something that isn't standard. The ultimate objective is to help prevent problems from happening, reducing line stop time and increasing process stability. If team members judge there to be any abnormality, they can use a rope switch and andon to indicate a problem has been detected. Here, a team member finds a problem and pulls the rope switch above the production line. A chime sounds, and number 26 on the andon lights up in yellow to inform the team leader that there is a problem at number 26 workstation. The team leader moves immediately to the workstation to investigate the situation and provide assistance. If the problem is solved in the prescribed section of the line, the team leader pulls the rope again. This turns the yellow andon light off, letting all production workers know that the line has returned to normal. If the abnormality cannot be corrected in the prescribed section of the line, it automatically stops. The andon light then changes to red. In this way, the color of the andon light lets everyone know the status of the production line at a glance.
So the JDoka, it can be by human to detect the abnormality or also by the machines. It is helpful tool or a concept. You can use any tool, whether detectors, sensors, rope, as you saw in the video, as long as it detects for you the abnormality. The Toyota production system, one of the reasons how the lean concept is being spreaded, and we have seen and experienced with their production, how it is reliable, and it is considered to be a benchmark for quality comparing to other cars industries. After we have talked about the Toyota production system and the lean concept, we have talked many times about the waste and the lean used to reduce the waste as the Six Sigma used to reduce the variability. What are the waste? What is the waste? Specialists, they identify the waste, which is the non-adding value activities, to be 7 types of waste. Excess production, that's mean overproduction, considered to be a waste. Overproduction means that more than the demand need. Waiting, which is translation of a time, it is a waste. Conveyance, transporting an item from a place to place, or transporting a product from a place to place, this is considered to be a waste. Motion, the movement of a person in the working area, it is a waste. The movement of equipments that is not added value to the process, it's a waste. Process, the process itself, it may have steps, or the processing itself, it is a waste of non-adding value. Inventory, which means stocks that you are keeping in your storage that are not sold, this is considered to be a waste. And the last type of waste is the most common, which is the defect. In implementing the lean, you are not going to eliminate all of those. You will reduce them to the minimum, and if it can be removed, then it is good. But if there is a step like a process or a motion that added value, this is not considered to be a waste, because remember, the waste is the non-value adding activities. If the waiting or the production or the excess production, or the motion, this is adding activity, adding value, then is not a waste. And that can be identified when you analyze the process or you analyze the manufacturing system. The Japanese refer to the waste as moda. Moda is the terminology for the waste, and those are the 7 types of waste. You are always targeting any one of them appears in the process or in the system to eliminate it or reduce it to the minimum. Now we will focus more on those pillars and discuss and explain those tools appeared under them. And we will start with the just-in-time, since the JIDOKA is a concept and it's been explained here. We will go on those tools under the just-in-time and explain them one by one. Let's start with the first one, which is the takt time. The takt time, they call it the beat or the heartbeat of the production system. Why they call it in this way? Because it gives you the amount of time that is where you design your process to produce your product or to perform your service transaction. It is the available production time divided by the customer demand. The available production time, that's mean the time you have in your factory or in your system or your organization. Let's take an example. If a factory operates 480 minutes per day and the customer demand is 240 parts per day, the takt time is you divide the amount of time you have in your production time over the customer demand, which is the 240. So you divide the 480 by the 240, and that is the takt time. So the takt time is 2 minutes, meaning that every 2 minutes you should have produced a part to your customer's demand. So when you design your process, you should have considered to work within this 2 minutes, how you can produce that part within this 2 minutes to fulfill your demand. And in this concept, or by applying this technique in your production, that means you are applying lean concept or just-in-time concept in the production system. The takt time, it is under the just-in-time concept. It is one of the tools that helps you to identify the time needed to produce to the customer demand, or to produce the parts or the service transaction to be proceeded to the customer demand. This is, maybe you think it is only for production or manufacturing. No, it can be also for the service. Think about a bank. What is the working hours or the operating hours? Let's say it's 8 hours. How many customers transactions you can serve during these 8 hours? What is the demand? How many customers they attend to your branch? How many service they require per day? From there, you can get the takt time. So you can perform and design the service time or the transaction time, or in the production, you can design the manufacturing time for every item. Moving on, just in time, with another tool, which is continuous flow. This is very common, and we have seen it a lot. If you have watched any of those videos, how it's made. If you search on YouTube under Discovery Channel, there is common commercial videos about how it's made, and it goes in industries and explain how food it's made, how equipment it's made, and you see how those equipments go piece by piece, or product by product, unit by unit, or batch of let's say chocolates, they go, or a patch of peanuts, they go to another process. So what is the continuous flow? It is producing and moving one item at a time, or small and consistent batch of items. Because some, for example, especially in the food industry, you may not be able to produce or work on or moving on item at a time, but you use a small batch and consistent and measured and weighted in gram or kilograms, and you move it one at a time through a series of processing steps. One for packing, one for grinding, one for cooking, one for labeling. This is for food. And for cars, one for the installing the engine, one for installing the transmission, one for the doors. So every step has a processing for the same unit or the same small or consistent batch of items. This is works continuously as possible. So the manufacturing work in this manner during all the operating hours, with each step making just what is requested by the next step. So in the next step, I need to cut those material. So you have to prepare the material in the previous step, for example, in a certain temperature, or it has to be in a certain alignment before it comes on the cutting tool, so you can do the cutting step correctly. So the definition of continuous flow, again, producing and moving one item at a time, or a small and consistent excuse me, batch of items through a series of processing steps as continuously as possible during the working hours, with each step making just what is requested by the next step. We see three different examples of the continuous flow here in the figure. This is a manual feed and watch machine cycle, meaning that a human is feeding the machine item by item, and he's watching the cycle and making sure every step is processed correctly. In the second time, you see a watch machine cycle that a person is only watching the automated feed. So is not manual feeding. feeding معناها التغذية للitems للprocess للconveyor حق البلت item by item by the human. Here no, it is by the machine, automatically it is feeded, and the human here it's watching to make sure that is conducted correctly for every step. This is a fully automated. The machine automatically feed the items item by item or small batch by a small batch, and it has automatic watching sensors or monitoring to detect any mistakes happen during the process for every single step. Those three different types, depending on the production or manufacturing system, how they can be implemented. It can be all of them implemented in different steps, or one of them, or combine two of them, but those all different type or scenarios of the continuous flow. So continuous flow can be achieved in a number of ways. So it is not only one way, ranging from moving assembly lines to manual cells. All of these can be conducted correctly under the continuous flow. Moving to the third tool under the just-in-time, which is a well-known name or a well-known tool, Kanban, and the pull system. Always when you hear the Kanban, you hear the pull system. What is the pull system and what does it mean, the Kanban? We will explain in this slide and the coming slides more information about them. The Kanban, it's a scheduling system for the lean manufacturing and just-in-time manufacturing. It categorizes the items or the units that you are producing into categories. For example, here, to do, that means it's a plant, or it is in the process or in progress, or it is done. So you can identify the status of your items at any point of time during the manufacturing process, whether it is planned, that means it's still material is not being processed yet, or it is in progress, or it is done. So basically the Kanban gives you that signal to tells you or to gives you the information about your scheduling system of your manufacturing items or transactions if it's service. The pull system is a method of a production control that in which downstream activity signal their needs to upstream. What is meaning and what is the downstream and upstream? Look into this picture. Imagine if this is a stock, مخزون, and the pull means that the downstream operator, he is the one pulling from the stock. The upstream operator, excuse me, he is the person that replenish the part where is the person of the downstream has taken it to process it or to ship it or to send it to the next step. So the empty space here, when that person has left item A from the shelf, that's considered the signaling from here that there is an item is missing. So the person has to replenish that part. This is considered to be the pull system. When we talk about the pull system and clarify it more, we have to identify what is the opposite of the pull system. Okay, we understood what is the concept that we have explained previously, but what is the regular, or what is the difference between the pull system and other system? There is in the manufacturing, also in the service, as we will see in a few, push systems and pull system. The push system is when you make all what you can just in case that there will be a demand. So you produce as much as you can. You remember in the first video when we have talked about the Toyota production system, and the Japanese, when they visited Ford factory that time, Ford that was already established and they are producing their cars. They were one of the leaders who starting the automated cars. They found there they couldn't produce as, or they cannot even build their factory or manufacturing as large as the Ford industry, because Ford industry that time was using push. Why? Because they were one of a few car makers in the world. So they were planning or targeting to produce as much as they can, so they can provide cars enough for the global market, because the market share was big that time for them. This concept, it is relying on production. The production is approximated, so it is not really accurate. It is approximated, is based on anticipation. Inventories are usually high, and there is always a waste in the system because they are producing as much they can regardless of the demand. On the pull system, you make what's needed when needed. So you make to order. In the push system, you make to stock. To stock عشان تخزن. Make to order, that's mean تبني الطلب للorder اللي جاك, or the request you have. So the production here is precise and it is based on actual consumption, and the inventory usually is low and the waste is reduced to the minimum. So the pull system, we can see how the lean concept, which is reducing waste, it is applying that in the production. So you build the item based on the orders. You don't build it just to stock it and then you look for customers to purchase it. Now, in different scenarios, the pull system, when it is facing seasonal demand, it has to be also calculated correctly and forecasted correctly before you come to a season when you have a high demand, and it will cause you also a delay to fulfill all the requirements if you don't have enough resources to produce your product or services on time. And this is, for example, a concept if we apply it like in Hajj season or in Ramadan also season, when we have a high demand for a certain things that happen. So for those companies or manufacturing who are working in pull system, as the production is precise, it is also has to consider the forecasting for those seasonal demand and plan it well before it comes, because if you are going just to produce, place on order, you may have a large volume of orders that you are not able to fulfill it on time. So it has to be studied and implemented very well before you consider it for any type of business. And this is the interesting about the industrial engineering. the industrial engineering, if you see until now, we are learning methods from the industry. The difference between industrial engineering, and this is the unique about it, comparing to other classic majors like electrical, mechanical, and civil engineering, with all respect, I'm not here to compare it, it's better or which one is better. All of them are needed and all of them are engineering fields. But what is unique about the industrial engineering compared to the classic majors, the classic engineering fields like mechanical, electrical, civil, the methods and the applications come from the science, from physics. 102, mechanical physics, that where you see static and dynamic material, or the electromagnetic physics, where you see the application in the electrical engineering. So it becomes from the science. In the industrial engineering, the methods comes from the industry itself. The industry found a problem. They solve it in a sequence and logical and studied manner. Then it is translated and converted into a discipline or into a method that taught in industrial engineering. As we see now here in the lean, it was found in the manufacturing, then translated also and abstracted into service industry until it becomes very wide and known and well known, and published many books about the lean, as well as for other concepts in the industrial engineering. Then here, where are you learn it so you can easily see it in real life and apply it in real life when you graduate. So let's continue. This was just a thought that how things are related to real life in the industrial engineering. Continuing with the just-in-time and the pull system, there are more than what we are covering in the pull system, but today we will focus on two types, and those two, the most two common types in the pull system. The first type, they call it the supermarket, and I will explain why they call it the supermarket pull system, is the most basic, and it is very widespread type. It is also known as A-type, also known as the A-type pull system or the supermarket pull system. Each process has a store. So if the packing process and the cutting process and the molding process, those three different steps or different processes, each one of them has a store. Has a store of what? Of tools, or a store of items that needed for that process. Hold that store, hold the amount of each product it produces, as well as it hold the related parts and related tools for that process. Each process simply produces to replenish what is withdrawn from its supermarket. We will explain. A customer requests an order, so the department schedule, send it to the scheduling department. They call it Hygienica here, and we will talk about the Hygienica later. They send to the processes steps to produce their parts or to produce their items. They have their own stores for the tools needed, for the parts needed, as well as for the finished items or the finished goods for each process. As soon the store is finished here in process one, so process one start to receive a signal from the customer so they can process and produce more items. If you think about it, why it is called supermarket, if you go to the supermarket, go, let's say, to any aisle in the supermarket, if you have taken items, let's say, Spanish from the vegetable aisle, and there was only left 3 or 4 Spanish bags there, comparing to all the other vegetables where are full, and they have enough vegetables in their carriage. So what they do, the supermarket, they will replenish that store of the Spanish. Go to any aisle, another aisle. Let's say that the milk aisle on the refrigerator, and one of the milk companies' aisle is being empty. So the supermarket pull system means that you have to replenish that category. Let's say Al-Mara'i or Nadik milk is being now finished, so they have to replenish it with other milk. So this is the concept of the supermarkets. It is also conveyed to the manufacturing, where they have each process, they have their own store, so they can store their products. As soon it is taken away from them, one at a time, that needs to replenish it based on the order of the customer. The other type, they call it the sequential pull system, which is also known to be as a B-type pull system. And it is used when there are too many part numbers to hold inventory, and it is for example here, the parts that needed and the tool, it can be stored for the process one as the same, the tools and the parts needed and the products comes out of this process, it can be held here in process 2. But if I have too many parts and too many tools, and it cannot be divided into separate stores, so in this case I will have a sequential pull system. And in the sequential pull system, the scheduling department, they determine the right mix of quantity needed for tools to be used for the production, and send the sequence list for the processing steps, first in, first out. That's mean the tools and the items goes to process 1, the first come, the first produced to the next process, then the remaining the same as well. In this case, we don't have store for every process, because every process will move on whatever they finish to the second process, because it is continuously going first in, first out. And the department in this step or in this phase, he is the one responsible to calculate the right mix and quantity of products to be produced based on the customer demand. More information now, we will see it in this short video that I will share it with you here, and it will show you the difference between the supermarket pull system and the sequential pull system. So bear with me here and let's watch the video.
Lean manufacturing is about reducing or removing waste from within a system or process. It's safe to say, then, that lean companies only make enough products to meet real customer demands. Therefore, no inventory of finished goods is maintained. A pull-based system of production and distribution is demand-driven rather than forecast-reliant. A pull system basically limits the amount of work in process, WIP, that can be in the system at a given time. Replenishing of supplies or production is determined according to actual customer orders that have been received. The sale of that product has already been negotiated. A pull environment will come from real demands and products only made to satisfy real orders. A work item can only be in process if there's a demand for it. This environment can be found or set at any level within an organization. We can visualize it on the production floor as well as in the flow of information between departments. A pull system is a control-oriented system that operates by receiving signals that more production is needed. There are two different types of pull systems, sequential and replenishment. Sequential pull is where the downstream personnel pulls parts from the upstream supplying process in the sequence in which the prior step produces it. Sequential pull limits the amount of inventory between the two steps of a process. The ideal output is one-piece flow. When we refer to one-piece flow, we mean that sub-assemblies are moved from step to step, one piece at a time, or a small batch at a time, minimizing work-in-process inventory. Replenishment pull is where the downstream personnel pull parts from a storage location according to what they need to complete their tasks. This is like how a supermarket works. So replenishment pull systems are also called supermarket systems. The parts removed from the storage location, or supermarket, are replenished by the supplying process. Lean uses a concept called Kanban, meaning signal in Japanese, to manage this type of pull system. Kanban uses cards to signal and communicate the need for more supplies. In the context of the flow of information, a pull system allows employees to pull their next task if they have the capacity to start working on it. This helps them to better prioritize tasks and prevents overloading, helping employees stay focused on executing the work. Let's visualize a couple of examples that would represent manufacturing pull systems. When standing at a workstation along the production line, we notice that there's only one footprint for the sub-assembly, which can be placed between Station 3 and Station 4. This is limiting the amount of work in process that the operator at Station 3 can produce. Upon removal of the sub-assembly by the operator at Station 4, the empty footprint signals the operator at Station 3 to replenish the sub-assembly. This controlled condition clearly represents a pull system in place. Another case would be when a box of components is being consumed and a card, a light, or other signal prompts material handling to bring over another box to ensure no interruption to the workflow. A pull system triggers the action only if the WIP limit has been reached. In this case, the WIP limit is met when half the box of components has been consumed.
So this was for the Kanban and the pull system. Let's move on to another lean principle or lean technique. Is a very famous concept technique is Kaizen, or before the Kaizen is, let's start with the Hijanka, and then we will go with the Kaizen. Kaizen is very well known, and I think many people are familiar with that one. Hijanka is maybe a rare, and it is very new to you. That's why it is one of the Toyota production system tools and techniques. The Hijanka means leveling. It is a Japanese term, and it means leveling the type and quantity of the production over a fixed period of time. And why they do that? This will enable the production to efficiently meet the customer demands while avoiding patching and resulting in minimum inventories, capital cost, manpower, and production lead time through the whole value stream. For example, here, let's say that the customer demand per week is 5 plain t-shirts, 3 t-shirts with a pocket, 2 t-shirts with the v-neck, and 2 t-shirts with the v-neck and pocket. The mass production will produce all the 5, then all the 3 with the pocket, all the 2 with the v-neck, and then all the other 2 with the v-neck and the pocket. Now, the Hijonka concept means, or the relying on leveling that the orders, if now we're talking about 5 only t-shirts, imagine if those 5 are 5,000 or 500. If you are going to produce the 500 and you consume all the working day just to produce the first one, you will meet the customer demand only on one criteria, and you may have to stock it that day until you complete the remaining 3. But when you leveling the production and use lean production concept, you can produce from all those types, for example, from the first day, and you can ship it, so your customer will keep receiving all the different products daily until he complete by the end of the week all his requests. Now, maybe because you see the concept with the lower number or less number, but if you go and enlarge it, then it will make sense to you to rearrange the production in a way. For example, here you produce the highest demand, which is the model A, 2 t-shirts, and then the sequence of the production will go to model B for 1 t-shirt, and then 1 with the v-neck and 1 with the v-neck and pocket. Then you go again to the 2 plain t-shirt, 1 with the pocket, and then and so on until you complete the orders. By this way, for example, by the first day of production, you have accomplished from all the types, even though you have not completed the quantity yet. By the end of the week, you completed all the quantities. In the mass production, you will complete the first maybe one of them by the first day, but all the remainings are still not yet. So leveling, that will be based on the demand and based on the priority also. Maybe the customer priority, it is for one of them, then this is also, it will be a factor in the leveling process. The Hijonka, maybe you think that is only in the production, and in how it is going to be in service, and it is hard to be and see it in service. I choose this video to show you how this concept of leveling the priority can also be implemented in service industry. It is a conversation in healthcare, and it shows you how this Hijonka can also be implemented there. So let's watch this also short video, and let's see how it can be implemented in different sectors than the production.
I'm glad you agreed to meet with me here, Doctor.
My pleasure. You were very helpful in helping me understand the concepts of 5S. And now that our facility has adopted that concept, the hospital is running more smoothly.
But there is something else I wanted to talk to you about.
What's that?
Well, have you noticed that our radiology department gets backed up in the afternoon just about every day?
As a matter of fact, I have noticed that.
Do you have a solution for that too?
Hi, Junka.
God bless you.
Thanks, but I did not sneeze. Hajunka is a Japanese word that means leveling or smoothing the workload, and that is what we need.
Interesting. How does it work?
Well, in this particular case, it appears that patients from our emergency department seem to be filling the radiology department in the afternoon. This causes delays. We are also scheduling non-emergency patients for tests at that time.
Right. So, should we just tell our ED to stop sending so many people during those hours? That would solve it, right?
Well, not exactly. If we wanted to smooth out or level the workload in this case, we would consider what we could control. And that would be the non-emergency patients.
That makes perfect sense.
Right. We would change the scheduling of our radiology department so that non-emergency patients would be scheduled at off-peak hours for our ED.
Excellent idea. Where did you come up with this?
Well, I learned about leveling work and Hajunka from my friends at EMS Consulting Group. www.
So the concept of hijanka in that hijanka in the healthcare industry or healthcare service, I intentionally took that example because it shows you that even leveling your patients and in that case the outpatient اللي هو المراجعين العاديين they are not the same as the priority of the emergency, and the emergency load usually comes in the afternoon. So you can schedule the outpatient out of that time where is the high demand of the radiology department by the emergency department. So the emergency department take the priority for the afternoon time, since it is the highest peak time for them, and then you schedule the outpatient and the regular patients during the other working hours. So the leveling here is the same concept. How you level your quantity of production or customers or service transactions, in a way you smooth the process. This was about the hijanka. Let's move on to the one of the very known and well-known tool, which is Kaizen. Kaizen, it is also, as the other terminologies, is a Japanese, and it is basically came from the two words Kaizen or Kaizen, change for good. That is the meaning of the Kaizen. It is how you can improve the process over and over, and that's why in quality they say there is always room for improvement. There is no process in quality that means it cannot be improved. Any continuous improvement for either the entire value stream or individual process to create more value with less waste considered to be a Kaizen. So Kaizen can work into two levels, either the level for the whole system, so focusing on the overall value stream, and this is Kaizen for management, or process Kaizen by focusing on individual process, and this Kaizen for work team and team leaders. There is a tool, a well-known tool, and maybe here we will talk in the coming slide after we finish, how we can integrate the lean with the Six Sigma. You can see many of the tools can be integrated with also some tools already in the Six Sigma, or you can use them separately in the improve phase in the Six Sigma process. The value stream mapping, it is similar to the process flow chart, but with the added of lean principle to it by identifying the time for every step in the process, so you can cumulate the total processing time, so you can trigger where you can reduce and where you can improve and where is the highest time is needed in the process. And that they call it the value stream mapping. We will learn more about the value stream mapping when we talk about the define phase in the coming session. Here also a short video, and it's very good. A video shows you about how also Kaizen was implemented in the Toyota production system, and brilliantly how involve everyone in the process to implement Kaizen to improve the process, either by adding value or by reducing waste. And remember the type of waste that we have talked about earlier. So let's watch now this short video.
I like that already. They've built me a screw dispenser. Oh, look at that. 2. No more than 2, no fewer than 2. And attaching the screwdriver to this cord means it's exactly where I need it. Okay, here we go with the new Kaizen, new improved steering wheel thing. Right, this is where it gets interesting. Got this screw. Straight on there. Straight there. Much better. Kaizen!
So interesting. You see how you involve everyone in the process to improve every step, and there is always room for improvement. That steering wheel where he was working on, maybe the other employee, they were used to get those 2 screwdrivers and implement them without any hassle. But you consider always there is maybe a new worker will come to the industry, that factory. So you hear from them. So where you can improve that process for anyone, a beginner has to perform that process as the expert with no chance for errors or mistakes and defects. So this is the Kaizen, how you improve the process or you improve the overall value stream. There is a term that in Arabic, and it is funny, they call it Kaizenha. That's mean improve it. So there is always a way to improve it and always room for improvement in the quality. The last tool or last technique we have under the Toyota production system and the Lean is the standardized work. The standardized work is one of the most powerful tools, but is the least to be used because it is hectic to do it. You have to document the best practices and standardize the work forms and the baseline for continuous improvement. Establishing the standardized work rely on collecting recording data on few forms. These forms are used by the engineers and the frontline supervisor to design the process and by operators to make improvement in their own job. The standardized work consists of 3 elements: the target time, the precise work sequence, the standard inventory. If you remember the work measurement or work study course, why did you take that course? Is to show you how by the practice you will memorize the steps and you will perform the task assigned to you in a better and in a short time. So those 3 elements, if you do them in your manufacturing or your service by documenting how you do the step, what tools or inventory you need to do it, the time needed, then you organize the work in your process or your industry or your organization or your department. In a way, any person hired in this place, he will perform the job in the same manner. What we see sometimes in whether restaurants, shops, stores, we see some employees, they serve us in a certain way or in a good way. Let's say you come after time to the same place, you see a different employee, he serves you or he performed the job in a less or long time. So the appearance of the standardized work, you see it in organizations where they perform their work or products all the time in the same way. Why? Because they have in written document the best practice, which include the tacit time, meaning that the time needed, the precise work sequence, meaning how you do it, and the last thing is what you need to do it, whether tools or software application or steps from a machine or whatever is that. That was all for the lean. I would like to share with you one of the tools that it is commonly known, and it is one of the major tools in the Six Sigma, which is the SIPOC, and we have learned it before. And you see how the lean, when it is integrated with the Six Sigma in implementing the make, you see here how you implement identifying the potential waste for every single step in the SIPOC or even in the process flow. In the process flow, when you identify the time, and that they call it value stream mapping, and we will see it later. Here, when you identify the waste, and what is the metric means how you measure that waste, whether it's a time or it is number of papers or it is any of the 7 types of waste that we have identified. What is the unit to measure it? And what is the customer requirement to improve it, whether to eliminate it, to reduce it, to make it easier, to explain it. So these 3 columns here, the colored one, this is integration of lean with the DMake and the SIPOC tool, and many other tools that you see it. Also, you have learned those other tools, they can be implemented separately in the improve phase to reduce waste and improve the performance and reduce defect as well, which also eventually you have and reduce the variability, which is the objective of the Six Sigma. That's all for today's lecture about the lean. I will leave now the time for the questions, and we'll see you in the next session with the make process.